Okay, I'm going to give two examples from page 521. The first one, 53, just so that we have a comparison to do number 57, which was a request because it was a little bit harder. So, example 53 asks you to find the component form of the vector, and they give you two pieces of information. They give you the magnitude of the vector equals 7/2, and then they give you the theta, which is 150, and that's measured from the x-axis, okay? So if you think of from the x-axis 150, it's somewhere over here, right? That's 150. So how do we find the component form of the vector? So from the stuff we did in the last section, you know that the component form of the vector written in this notation would be cosine theta sine theta. And then it would be times some magnitude. All right, well, what do we have? We have a magnitude of 7/2, and we have a theta of 150. So I do cosine 150 sine 150. Now it's easy. I just need to know what is the cosine of 150. Well, 150 is really a 30-degree triangle, right? And again, we're always working with right triangles. Opposite the 30, half the hypotenuse, 1, 2, 1 √3. Any positives or negatives? Oh yeah, √3 is negative, 1 is positive, hypotenuse always positive. All right, so here's the final answer. 7/2. What's the cosine of 150? Negative √3 over 2. What's the sine of 150? 1 over 2. There we go. Need to simplify it though. So final answer would be negative 7 √3 over 4, 7 over 4 in the component form notation. So there we go. That's number 53. So number 53. So now, how do I do number 57? All right, number 57. Well, what do they ask us for and what do they give us? They want the component form. All right, so we've been there. They give us the magnitude is 2. Magnitude of V equals 2. Oh dear, they don't give us the angle in the form we're looking for. They say the vector is in the direction of I plus 3j. So we need to figure out what angle is that talking about. Oh boy, I think you know. Sketch it. Let's sketch it up on that same axis. Okay, so when I sketch it on this axis, I go over 1 up 3. There we are. I'm going to draw the vector in there. Now, here we needed the angle to get the sides. In this one, since we have the sides are given by these numbers, I know that this side is a 1 and this side is a 3. I can still figure that hypotenuse, 1 squared plus 3 squared, that's 10, square root of 10. So square root of 10 is the hypotenuse. All right, there's our numbers. So how do I do it in component form? It's going to be 2 times the cosine of that theta, the sine of that theta. Oh man, I don't know the angle. I don't need it because I can still do from that figure the cosine and the sine. So you don't need to whip out your calculator and do inverse functions to find the angle because we really don't need it. We only needed it to find the values here. So what's the cosine of that value? 1 over √10. What's the sine of that value? 3 over √10. Okay, let's finish up simplifying the component. I need to multiply by 2. So that would be 2. Well, let's write that a little better. How about 2 over √10 and 6 over √10. Can I leave it like that? I hope you said no. What's wrong? Can't have a radical in the bottom. So 2 √10 over 10, 6 root 10 over 10. Can I do anything else? Oh yeah, let's reduce it. You know how to do that. So, root 10 over 5 and 3 root 10 over 5. Easy as pie. So, don't stress when they don't give you the angle. Use the linear combination here to sketch the angle. All you need is the sine and cosine. You don't officially need to know exactly what that angle is. All right, you're good to go.